Hello everyone. Today I'm going to discussing about one of the Spark important interview question, that is what is the difference between repartition versus Coalesce. Coming to concept wise, in Apache Spark, repartition and Coalesce are used to modify the number of partitions of a data frame RDD. Okay, that means these two functions will help you to control the number of partitions for your data frame and RDD. Okay, using these two functions, you can increase the number of partitions and we can decrease the number of partitions. Okay, mainly why we are using these repartitions and policies in the sense to control or optimize the performance and resource utilization control. Okay, now coming to main thing, what is repartition? Here repartition is one of the function, and we'll use these repartition functions to increase the number of partitions for existing RDD data frame, and we can decrease the number of partitions for existing RDD data frame. So if you use the repartitions, it will perform the full shuffle across the cluster. That means it will shuffle the data between the partitions from the across the cluster. Okay, let's take one example. Below is the one example. So currently my data frame is in 4 partitions. Now I'm planning to change that 4 partitions to 8 partitions using the repartition number. Okay, repartition function. So whenever if you use this function, what happen? It is shuffling data from 4 partitions to 8 partitions. That means full shuffle is happening across the cluster. Okay, and the data is available on all the 8 partitions. Now, what is the use case example for this repartition? So when we are going to use this one, the main purpose of this repartition is if you are planning to write use set of data set or data frame to the disk, then repartition will help you because of this repartition can improve your parallelism. That means parallelism in the sense you can read the data from source and write into the destination, that everything is happening from the parallelism. Let's take one example. If you're having 8 partitions, so 8 files, maybe it will copy from source to destination. If you are having the 12 partitions, it will copy 12 files from source to destination. If you increase the number of partitions, the parallelism also it will increase. That is the main scenario. Coming to example wise, see here, I'm reading data from one of the last CSV file using spark.read.csv, and I'm doing repartition using the 12 partitions. That means, so it will create 12 partitions and it will write data into the output folder for 12 partitions. That means it will process 12 parallelism tasks. Okay. So next one is, what is Coalesce? Coalesce in the sense, I already mentioned, it is also one of the optimization techniques to control the number of partitions. But the main difference between repartition versus Coalesce is, this Coalesce only we can reduce the number of partitions. It is not possible to increase the number of partitions. So, and if you use this Coalesce, it will avoid the full shuffle. That means it will shuffle the data for some specific partitions because of we're trying to reduce the number of partitions. Okay, below is the one of the example. So initially my data frame is in 8 partitions. Now I'm updating that 8 partition to 2 partitions for the specific data frame. So here what it will happen, so only 2 partitions data will be shuffled, not for entire 8 partitions. Okay, so now data is merged into 2 partitions without full shuffle. Okay, this is the thing. And what is the use case of this policies? Let's take one example. If you're having a smaller data sets or small data frames, in that time, what happen if you use the policies, it will help to reduce the overhead. So below is the one of the example. So df is called spark.read.csv. So I'm reading a small file, and you have that policies. I'm using only one partition. That means in our output folder also it will store only one partition data. So what are the main key difference for this repartition policies? So first one is repartitions. We can increase or decrease the partitions, and it will do the full shuffle. So that is the reason that operation is very slower. Better distribution, because of you are increasing the number of partitions, definitely that distribution will be high. So coming to Coalesce, only we can decrease the number of partitions. No full shuffle. It is a very faster because of we are decreasing the number of partitions. Less control over distribution. That means we are reducing the number of partitions. That means the distribution is very less. So when to use? When to use exactly? So as I told earlier, if you want to increase the number of partitions, you can go with the repartition for better parallelism and processing for saving larger data set. If you want to reduce the partitions, like optimize performance while writing the small data set. If you're having the small data set, then you can go with the policies. That's it, guys. Thanks for watching my video. If you like my video, please share, like, and subscribe. Thank you.